In this video, we are going to talk about the LIATE rule. The LIATE rule is an abbreviation. The L stands for logarithmic functions, and then the I stands for inverse trigonometric functions. So for the logarithmic functions, we have examples such as the natural log of x, log x. And then the inverse trigonometric function, we have the sine inverse of x, tan inverse of x as examples. And then the A stands for the algebraic functions, which is the x, x squared, those kind of functions. And then the T stands for the trigonometric functions. Example is the sine x, cos x. And then the E stands for exponential functions, which is the exponent x, a constant exponent x, and so on, as examples. Now, this LIATE rule is very important because it also falls under the integration by parts. Now, if we are given two functions, maybe let's say integral of v of x times u of x. Now, based on the already existing principles that we spoke about in integration by parts, we know that we need to look for one of the functions so that we'll differentiate one and integrate the other. Now, what happens is that for what we have done so far, this is a complete guess. So to remove the guess and know the exact function to differentiate, that is where the LIATE rule comes in. With the LIATE rules, what comes first is the one to differentiate. So it tells us which one we should use as our u substitution. So if we have a function that contains, for example, let's say we have a function like x natural log of x. You see that this function contains x, which is an algebraic function. And then it also contains ln x, which is a logarithmic function. Now, when we check the LIATE rule, you see that the logarithmic function comes first before the algebraic function. So therefore, in this case, our u becomes ln x, and then our dv becomes x. So the LIATE rule gives us a perfect understanding of what to do in the instances where we are supposed to use the rule for integration by parts. So let's take some examples and then explore the rule properly. So we have this question here, which is to evaluate the integral of sine x natural log of into bracket cos x dx. So we need to use the LIATE rule to know which one becomes our u substitution. Remember, the u is the one we differentiate. Now, if we check the function that we're given, this sine x is a trigonometric function, and then the natural log is a logarithmic function, and then this is a trigonometric function. But because it's part of the natural log, we'll consider all of that as a logarithmic function. So we are talking about the product of a trigonometric function and a logarithmic function. But if we check the LIATE rule, the logarithmic function comes first before the trigonometric function. And therefore, in this case, our u is equal to natural log into bracket of cos x. So the u in this case is equal to, now we differentiate what is inside the bracket. If you differentiate cos x, you get minus sine x. And then we differentiate the whole thing, so divided by cos x dx. So this is the u. And then now the next thing is to find dv. Dv is equal to what is left. So what is left is sine x dx. So v, if you integrate sine x, you get minus cos x. So now remember the formula for integration by parts. We said that integral of u dv is equal to uv minus integral of v du. So this is equal to, our u in this case is natural log of cos x, and then v is minus cos x. So minus cos x, then natural log of into bracket cos x, then minus integral of v is minus cos x, then du. So let me put it here, minus cos x times du. Du is minus sine x divided by cos x, then dx. So you see that this cos x and cos x can cancel. So we are left with minus cos x, natural log of into bracket cos x, then plus integral. Sorry, this minus 1 times minus 1 will give plus 1, but there's already a minus here. So this minus times, so minus integral of sine x dx. So this is equal to minus cos x, minus cos x, natural log of cos x. And then now if you integrate sine, you get minus cos. So you get minus into bracket minus cos x plus the constant of integration, so plus c. So therefore this becomes minus cos x, natural log of into bracket cos x, then plus cos x, and plus the constant of integration c. So integral of sine x, natural log of into bracket cos x dx is equal to, now I want to write this first, which is cos x minus cos x, natural log of cos x plus c. So using the same ILATE, let us solve integral of sine inverse of x dx. Now you can see that this is a product of two functions. Let me rewrite this as integral of 1 times sine inverse of x dx. Now 1 times sine inverse of x dx is the same as sine inverse of x dx. So you can see that this one is an algebraic function, and then the sine inverse of x, this part, is the inverse trigonometric function. Remember that the rule is the LIATE rule. So when we use the LIATE, you see that I, which is the inverse trigonometric function, it comes first before the algebraic function. So in this case, our u is equal to sine inverse of x. So du in this case, now if you differentiate sine inverse of x, you are going to get 1 divided by square root of 1 minus x squared dx. And in this case, dv is equal to 1 dx, which is the same as dx. So v is equal to x. And therefore, integral of sine inverse of x dx is equal to, remember the formula is uv. So our u is sine inverse of x and v is x. So x sine inverse of x, then minus integral of v du. V is x, then du, so times 1 over square root of 1 minus x squared dx. So this is equal to x sine inverse of x, then minus integral of x divided by 1 square root of 1 minus x squared dx. Now, if you differentiate what is inside the square root, if you differentiate 1 minus x squared, you will get 2x. Sorry, you get minus 2x. But the numerator is what? Is just x. So we need to make sure that the numerator looks like minus 2x. So the way to do is to say this is equal to x sine inverse of x, then plus, I want to push minus 1 inside, integral of, however, I want to have minus 2x and the numerator. So I need to multiply by 1 over 2, so that we will now put minus 2x divided by the square root of 1 minus x squared dx. So you see that this minus can come out to give us this minus, and then 2 will cancel these 2, so we'll get back our original function. And then this is equal to x sine inverse of x and plus half of, now if you integrate all of this, it is the same as 2 times square root of 1 minus x squared, then plus the constant of integration c. Now if you don't understand why we are getting this result, I've already done a video on how to integrate this kind of functions. I will link it in the description, so you can watch that video to understand why it is like this. So these two and these two can cancel out, and therefore integral of sine inverse of x dx is equal to x sine inverse of x, then plus square root of 1 minus x squared plus the constant of integration c. So we have another question here, which is to solve integral of into bracket natural log of x all squared dx. So let me rewrite this as integral of 1 times into bracket natural log of x all squared dx. So you can see that this one is an algebraic function, and then natural log of x is the logarithmic function. The rule is the LIATE rule. So logarithmic function comes first before the algebraic function, and therefore our u is going to be equal to natural log of x all squared. So du is equal to, you first differentiate what is inside the bracket. If you differentiate ln x, you get 1 over x. Then you differentiate the whole function. So times 2 will come down. Then multiply by natural log of x. Exponent 2 minus 1, which is 1. So it becomes like this, then dx. So let's rewrite this well. So this becomes du is equal to 2 over x ln x dx. Now, our div is what is left. What is left is 1. So our div is equal to 1 dx. So v in this case, if you integrate dx, you get x. So therefore, integral of into bracket natural log of x all squared dx is equal to u v. So v is x, and then u is natural log of x all squared, then minus integral of v is x, then du is times 1 over x, then times 2, okay, so I'm writing from this, then times 2 natural log of x dx. So this 1 over x and x will cancel out. So this is equal to x into bracket natural log of x all squared, then minus, I'm pulling out the constant, which is 2, integral of natural log of x dx. But you see that we cannot also integrate this one straightforward. So the next thing we need to do again is to take this aspect through integration by parts. So let me do that here, which is integral of natural log of x dx. So you see that this one too is also a product of 1 times natural log of x, but then 1 is an algebraic function, and then natural log of x is a logarithmic function. So our u in this case is equal to natural log of x. So du is equal to 1 over x dx, and then dv is equal to 1 dx. So v is equal to x. So integral of natural log of x dx is equal to u v, which is x ln x, minus integral of v x, then times du is 1 over x dx. So this is equal to x ln x minus integral of dx, and that is equal to x natural log of x minus x. So we have found integral of natural log of x dx, so we just replace it. So this is equal to x natural log of x all squared minus 2, then all of this becomes times x natural log of x minus x, so plus the constant of integration c. So let's expand, and this is equal to x natural log of x all squared minus 2x natural log of x, then plus 2x, then plus the constant of integration c. Evaluate integral of natural log of x divided by x squared dx. So still we need to use the LIATE rule. So let's rewrite this integral as integral of x exponent minus 2, then times natural log of x dx. So you see that this is an algebraic function, and this is a logarithmic function. So LIATE rule, LIATE is like this. So logarithmic function comes first before an algebraic function, and therefore our u is equal to natural log of x. So du is equal to 1 over x dx. So now dv is equal to x exponent minus 2 dx. So v, when we integrate that, if you integrate this, you get minus x exponent minus 1 dx, which is the same as v equals minus 1 over x dx. And therefore, this integral, which is integral of natural log of x divided by x squared dx, is equal to u v. U is natural log of x, and then so natural log of x times minus 1 over x. Sorry, I made a mistake here. I added the x, which was not supposed to be so. Then minus integral of v du. V is minus 1 over x. Then du is times 1 over x dx. So this is equal to minus 1 over x, natural log of x, then minus, however, this minus 1, here's minus 1, so here becomes plus. Integral of 1 over x times 1 over x is 1 over x squared dx. So this is equal to minus 1 over x, natural log of x. If we integrate 1 over x squared dx, that is what we did here. We did that here, and we got minus 1 over x. So here becomes minus 1 over x plus the constant of integration c. So what we can do in this case, we can factorize minus 1 over x out. Then we are left with natural log of x plus 1, then plus the constant of integration c. So we have this question here, which is to solve integral of x sine x cos x dx. Now, let's use some trigonometric identities here. What is sine 2x? It's equal to 2 sine x cos x. So it implies that sine x cos x is equal to half of sine 2x. So this implies that this integral becomes half of integral of x sine 2x dx. Now you can see that this part is the algebraic function and this part is the trigonometric function. So using the LIATE rule, you can see that the algebraic function comes first before trigonometric function, and therefore our u substitution, u is equal to x. So du is equal to dx. Then dv is what is left, so that is sine 2x dx. So v in this case is equal to, now if you integrate sine 2x, you get minus 1 over 2 cos 2x. Now it means that integral of x sine x cos x dx is equal to half of integral of x sine 2x dx, and then this is equal to half, then bracket open, so it becomes integral of this is uv. So our u is x times v. V is minus 1 over 2 cos 2x, then minus integral of v du. Now du is dx, so v is minus 1 over 2 cos 2x dx, bracket close. So this becomes, I'm pulling the minus 1 over 2 out. So 1 over 2 times minus 1 over 2 is minus 1 over 4 x, then cos 2x. Then here is 1 over 2 times minus 1 over 2 is minus 1 over 4 times minus 1. So here becomes plus 1 over 4 integral of cos 2x dx. So this is equal to minus 1 over 4x cos 2x. Then if you integrate cos 2x, you get 1 over 2 sine 2x. 1 over 2 times 1 over 4 is 1 over 8 sine 2x, and plus the constant of integration c. Evaluate integral of 1 over x times into bracket ln x all cube dx. So let's rewrite this integral as integral of x exponent minus 1, then ln x exponent minus 3 dx. So you can see that this is an algebraic function and this is a logarithmic function. So using the LIATE rule, you can see that logarithmic function comes first before the algebraic function. So our u is equal to natural log of x exponent minus 3. So du is equal to, differential was in the bracket. If you differentiate ln x is 1 over x. And if you differentiate the whole thing, minus 3 will come down. Then times natural log of x exponent, you subtract 1, you get minus 4 dx. So if we rewrite this way, it becomes minus 3 over x. Sorry, this becomes minus 3 divided by x natural log of x all exponent 4 dx. So this is du. Now the v is what is left. The v is equal to x exponent minus 1 dx. So if you integrate this to get v is equal to, if you integrate 1 over x, is the same as natural log of x. So integral of 1 divided by x natural log of x cubed dx is equal to u v. This is v, natural log of x, but u is the same as 1 over natural log of x exponent 3 times v is natural log of x, minus integral of v, which is natural log of x, then times du. Du is minus 3 divided by x into bracket natural log of x exponent 4 dx. So this is equal to, now this natural log of x will cancel 1 here, so we will be left with 1 divided by natural log of x all squared. However, this is integral of 1 over x times natural log of x all exponent 3, then minus, now this natural log of x will cancel 1 here. So if I pull out minus 3, here becomes plus 3 integral of 1 over x times natural log of x all exponent 3 dx. So you see that this and then this looks the same. So in the next step, it's going to be integral of 1 divided by x times natural log of x all exponent 3 minus 3 integral of 1 divided by x times natural log of x all exponent 3 dx. And this is equal to this, which is 1 divided by natural log of x all squared. So here we'll be left with minus 2. So here will be minus 2 integral of 1 divided by x times natural log of x all exponent 3 dx equals 1 over natural log of x all squared. So if we divide through by 2, we find out that integral of 1 divided by x times natural log of x all cubed is equal to minus 1 over 2 times natural log of x all squared plus the constant of integration c.